Good morning. We're finally coming out of lockdown and hopefully getting back to some sort of normality. And I wanted to reflect on the strange year gone by. We at 3D Scanners continued to operate throughout the previous year and we're busy supporting our customers. We even called each one of our customers to see how they were doing and to see if we could help. To help our customers, Innometric announced a promotion whereby any customer could get a free 3-month license of PolyWorks to enable people working from home to write offline programs and create reports. We quickly adapted our training courses to be effective when done remotely online, and customers found them very useful. Now we will continue to offer remote online courses as well as at our new facility in Warwick and at customer sites. We continued to make video tutorials, and these can be found on our newly launched website. Just a few months ago, we were here to introduce Innometric's enterprise solution and the addition of PolyWorks Data Loop to their PolyWorks product portfolio. We demonstrated users storing 3D measurement data in a centralized database and sharing inspection projects in real time, accessing 3D measurement data quickly and easily through a search engine, managing user permissions to control who has access and what can be done with the data, and using digital collaboration tools to communicate with colleagues. Today, we intend to take it one step further. We will demonstrate how to overcome the challenges of responding faster than ever to changing markets and the increasing complexity of products and processes through digital transformation strategies. This is the story of Innometric's own digital transformation journey. 14 years ago, Innometric's software development team supported their work with a sophisticated digital platform. The problem was that all the other departments were working in their own silos using their own processes. So Innometric took their first transformation step by implementing a customer relationship management system. That provided the sales and technical support team with a central database to manage customer accounts. 3 years later, they selected Microsoft Office 365 as their email and calendar platform and connected it to their CRM. By 2017, they had achieved a major goal. Their CRM system was linked with all departments dealing with customers, marketing, administration, and accounting. Then they integrated Microsoft SharePoint and Teams to centralize documents, manage business processes, and facilitate digital collaboration. 2 years later, they finally added the development team to their digital infrastructure. During their digital transformation, they eliminated the silos between the teams by deeply connecting multiple digital platforms. This tight digital integration of their teams allowed them to deliver superior products and first-rate customer service. In May 2020, early in the pandemic, they released PolyWorks 2020 right on schedule. They produced 90 promotional videos and began training new customers online. And they accomplished everything in 2 months with fewer than 5 people in the office because they are a digital enterprise. I'm telling you this story because the digital transformation journey that we are proposing for your 3D measurement processes is identical to the one Innometric followed over the course of 12 years. To successfully transform their processes, they learned that it's essential to get approval and support from all team members. And the business must remain fully functional and profitable throughout this journey. They succeeded in their digital transformation project because they implemented it gradually. And here's the 3-phase recipe that worked for them. In phase 1, you select and deploy a digital platform while staying as close as possible to the standard platform configuration. At this stage, it's too early to configure the platform deeply because its impacts on your processes are still unknown. And since the team hasn't mastered the platform yet, you can't use the feedback to identify and prioritise the next steps. Phase 2, after initial deployment, start consolidation, where your teams learn how to use the digital platform and integrate digital tools in their daily work without significantly disturbing existing processes. During consolidation, you should already be getting a significant return on your investment. If not, you might consider the choice of platform. While your teams acquire new digital skills, they will begin to identify potential efficiency gains. In Phase 3, once the teams have mastered the platform and are ready to contribute, you digitalise and optimise processes one at a time. This is when you tailor the digital platform to your needs and maximise its benefits to your company. PolyWorks now offers an advanced digital platform that boosts your operational performance on day one without disturbing your current processes. Today, in addition to highlighting the key benefits of PolyWorks 2021 digital platform, we will demonstrate the ultimate destination of your digital transformation journey: digital 3D measurement processes.
Good morning and welcome to the Changes and Improvements presentation. The following presentation is divided into 4 main topics: the PolyWorks Metrology Suite, changes and improvements to PolyWorks AR, Nurbs surfacing within PolyWorks Modeler, and finally an improvement to the Airfoil gauge segment analysis tool. As mentioned, the first part of this presentation is going to look at the changes and improvements to the PolyWorks Metrology Suite. More specifically, the first topic within the Metrology Suite will be regards to the versioning changes. First off, a little bit of background information regarding the Metrology Suite. Back in 2014, PolyWorks was revamped as the Metrology Suite. In 2018, the versioning of the new products was defined and implemented, including Data Loop, PMI Plus Loop, Report Loop, and also PolyWorks AR. Now, in 2021, there has been an improvement to the versioning aspect of the software. So the reason for the impending changes are due to the main issues you can see here. Before 2021, several different version numbers were deployed in the same cycle, which can cause compatibility confusion. The lack of coherence has impacted before, during, and after the deployment. The impacts of this make for difficulty reading compatibility tables and an overload of information involved in release announcements. In the past, versions with the same number have been incompatible. For example, the 2020 1.4 version of the Data Loop web interface server and also the Data Loop core were incompatible. A solution to this confusion, though, has been implemented. All versions of products deployed in the same cycle have been synchronized. The versions will be driven by the monthly deployment cycle. The release notes will all be in one document per product. For all products, there will be a major, minor, and potential fix release. The versioning rules moving forward will be that all products are synchronized with the annual launch cycle. For PolyWorks 2021, the major release was April. The international release is planned for June, and there will be no release in August this summer. Releases are linked to the monthly development cycle, although some software releases may not be deployed every month. Therefore, some minor versions will not be deployed depending on the software. Deployed versions will be added to the release notes, and for compatibility, the major annual release is the primary target for compatibility break. Software releases with the same version identifier will be compatible to avoid past issues, similar to the one I mentioned earlier, with the 2 Data Loop versions being incompatible. You can see here the planned 2021 versioning along with their release months. Note that there will be no release in August except for any required hotfixes. The benefits of this are that it simplifies the understanding of versions, and it enables the assumption of the compatibility of software with the same minor version. For example, the Metrology Suite 2021 IR4 is compatible with Report Loop 2021 IR4. A brief mention now about supported Windows versions moving forward. PolyWorks 2021 is the last version of PolyWorks to support Windows 7 and Windows 8. PolyWorks 2022 will no longer support either of these two Windows versions. Now, for an addition to the support information available from your PolyWorks supplier. Technical support contact information will now be accessible within the Metrology suite and also the individual modules, including Inspector or Modeler, similar to how you would see the About PolyWorks menu. The information you see will depend on the active license key. Node lock keys will show software support and development information, whereas floating keys will only show the software development information. Those with node lock keys will see 3D scanners as their software support contact, along with Innometric as software development. Customers with floating keys will only see the software development information. The next topic I'm going to cover with you is the changes to how backups are restored within PolyWorks 2021. Now, some of the regular users of either Inspector or Modeler may be aware of the automatic backup. This process is designed to restore as much information as possible after a software crash. The default for the automatic backup is set to 30 minutes, but this can be changed, however, within the options of the project. Shown here for you. Some issues have been identified, however, with this behaviour. Firstly, future developments require a modification to this particular behaviour. There is a lack of uniformity when working on a computer versus working with PolyWorks Data Loop. Another issue is that the module does not launch automatically, and the accumulation of recovered pieces within a project can also be an issue. Lastly, it is difficult to merge information contained in both the original and recovered project into one project. Now, in PolyWorks 2020, when working on a computer, PolyWorks will create a recovered project, at which point it is highly recommended the user opens the project as soon as possible to maximize the data recovery. This keeps one piece within the project. Now, when working with Data Loop in 2020, there is no project recovery. The user is prompted with a message to either recover an automatic backup of the piece or discard the backup entirely. And there we have a recovered piece has been displayed. But now, moving forward with PolyWorks 2021, the user now has a choice. In PolyWorks 2021, the interface has now been redesigned and the behaviour has also changed. The behavioural changes now gives the user three choices, and a choice must be made. It is immediately applied without regard to the restart or close buttons. The choice that is applied is the one that is selected. If a project unexpectedly ends, the user firstly can either keep the automatic backup, which will leave them with the last automatic backup, dependent on the time interval set within the project's options. Secondly, the user can choose to keep the last saved project, overwriting any previous automatic backups. Both of these options will leave the user with just one piece in the project. If the user chooses the third option, which is to keep both the automatic backup and the last saved, there will only be one project from now on rather than a recovered version, along with the creation of a piece titled name of the piece and then in brackets automatic backup. The pieces are now identified as follows. Piece 1 is the last saved manually by the user, and piece 1 is the automatic backup. When working with Data Loop, the automatic backup is local. It then needs to be uploaded to the database. Now, if at any point the workspace manager crashes, there is the automatic backup piece saved in the project. Again, there is still only one project and not multiple ones seen in earlier releases of the Metrology suite. Now, we move into the improvements for the user experience within the Metrology suite, to be followed by a short demonstration on some of these improvements. Identified issues from previous versions include long lists of items or objects, and also the apply and close buttons at the bottom of the interface are not easily accessible. There is now a search box available when there are more than 15 objects in the list. It is worth noting here that screen resolution does not affect the amount of objects required to access this list. Furthermore, the Select Interactively tool available next to many different drop-down lists has been added. And those of you who are unaware, this is the Select Interactively icon. The Object Properties window has been improved as well. The Apply, Close, Next and Previous buttons are now always available, instead of having to scroll down and locate them. The Previous and Next buttons have been replaced by Next and Previous arrows. And to finish, the Auto Apply has been moved from the Object Properties window to the Project Options. Now, in 2020, it is not possible to view or edit numerical parameters for dependent features. Users have to recreate the entire chain of objects or operations when a modification must be made. What they would need to do is create new dependent features. But now in 2021, you can now edit numerical values for dependent features. The benefits of this improvement include the visibility and traceability of numerical parameters, the flexibility of being able to edit numerical values if incorrectly entered or need modifying, and finally, it is more efficient as there is no need for the user to delete the feature and start over. Now, the following is the list of parameters that can now be edited within 2021 following this change. So you've got offset, length, distance, radius, height, slope, step, and also tolerance. So I'm now going to demonstrate to you some of these user experience changes I've just been showing you in the presentation. So I'm just going to come out of my presentation and open up our workspace manager. I'm just going to open up this predetermined inspector project. So just wait for that to load for a second. Now you will see here, those of you familiar with 3D scanners and possibly our training courses may be familiar with this part. A sheet metal part here that I've created some comparison points on. Done an initial best fit alignment as it was scanned, extracted some features, and then we've performed a DRF on it. So what I'm going to do, just to show you a few of the new changes that you can do in here, the first thing I will show you is the dependent features. So on here we have if I just turn all this off, we have the CAD, and we also have datum plane A here. So to show you the changes that have been made to the dependent features, I'm going to create an offset plane to show you how you can edit the numerical values. So what I'm going to do is, first of all, I'm going to go to create plane feature from my features menu. I'm then going to change my method to from objects and then hit the drop down for my sub method. Now, as I mentioned, you will see this a few times in this demo. We have the search available here. So I can type in there planes, begin to type in planes and offset, and you'll see here it's there. So instead of having to search for it, it's already there. Just jump back to my tree view. So I highlight datum plane A, so it's now highlighted. Go back to my dialog zone, and what I need to do is type in an offset value in here. So I can say, for example, 20 millimeters. If I now hit create, you will see here that we now have a offset plane, plane 3, which has been offset 20 mil from datum A. Now, as I said, in 2020, you were not able to now edit the value of that offset. You would have had to delete the plane and start again. Whereas in 2021, if I right click on plane 3 and go to the properties, if I jump into the dependencies tab, you'll see that our source object is datum A, and we've also now got our offset parameter down here. So I'm now able to go in and edit this to 25, and you will see this move in a second. Just to mention as to something else that I showed you in the presentation, the next and previous and apply and close buttons are now always available at the bottom of the properties window. So if I now hit apply, you will see that move there. So yeah, that is how you can change a numerical value. So that is just one example. As I mentioned, there are many others that you can change as you go along. Now, you may have noticed when I loaded this up, we do have some comparison points on here. So we have some trim edge points, and we've also got the back points created with those. So you will see here, if I zoom in, we have trim point 7 here is missing the back point. So just to demonstrate the select interactively tool to you, what I can do is go to create surface comparison point. I can then anchor a comparison point on this face here. close to trim point 7. So that has been extracted for us, which is good. So you see here surface point 3. You can rename that at any point if you want to. And then what I'm going to do is link trim point 7 to surface point 3. So what I can do is expand my object group, find trim point 7, go into the properties by double clicking if you prefer, jump into measurement, and then offset. You can see here that I can select relative to comparison point. So if I use the select interactively icon, I can then select surface point 3, and you will see now, again, hit apply afterwards, and that will now be linked to trim point 7. So if there's any deformity in the part, trim point will be affected by the change of surface point 3. So just a few things there to show you in the new user functionalities in 2021 Metrology Suite, so Inspector. We now move into part 2 of this presentation, where we will look into the changes and improvements for PolyWorks AR. A note to start off this part of the presentation is the support for HoloLens within AR. In PolyWorks AR 2020, the first and second generations of the HoloLens are both supported. For those of you who are unfamiliar with the HoloLens, you will see on screen now the first generation and now the second generation. Moving forward, a decision has been made as developing PolyWorks AR for both of these generations takes more time. Supporting the first generation prevents Innometric from implementing new technologies into the second generation. And finally, Microsoft no longer actually sells the first generation of HoloLens. Therefore, PolyWorks AR 2021 will not support HoloLens 1. PolyWorks AR 2020 1.6 will be the last version to support the HoloLens 1. Unfortunately, there are no benefits of the decision for the users themselves. All of the benefits are for the development team. Having only one generation to work with means it will be easier for them to maintain the code and also easier for them to implement new functionalities for the user. A word now on the AR package and the licensing information necessary for this particular product. Now, in 2020, PolyWorks AR was only available with a PolyWorks Inspector Premium license. Within the PolyWorks Metrology Suite License Manager, it was using the PolyWorks Inspector Premium Add-ons token. But now, in 2021, there is a need to make PolyWorks AR available for both probing and gauging workflows. Consequently, PolyWorks AR now has its own token within the License Manager. To summarise, in 2020, PolyWorks AR was only accessible if the user had an Inspector Premium license, whereas now in 2021, it is now possible to use PolyWorks AR with a PolyWorks Inspector Probing and a PolyWorks Inspector Gauging license. This has been enabled to aid new added workflows that I will discuss with you all shortly. In PolyWorks AR 2021, the part localization workflow has also been modified. In PolyWorks Inspector 2020, the user would have had to have needed to activate the augmented reality plugin from the Workspace Manager options, and then within Inspector would need to access the Tools menu, Augmented Reality, and then launch the Model Target Generator. Once you have selected the Model Target Generator from the Tools menu, if not already, the user would have had to have been required to install Vuforia Engine, which could only be achieved with an internet connection. Within this software, the user would have had to have selected the HoloLens icon to establish the in-use hardware, then access the model attributes to determine orientation and units, then create the guide view, and then only once these steps have been followed, generate the model target. The solution in 2021, Vuforia is no longer required to create the model view. This is achieved directly within PolyWorks using the HoloLens. So now for the part localization process, the user will have to now download the Open PolyWorks Inspector project using the PolyWorks AR app for the HoloLens. Once downloaded, the user will have to manually locate the hologram onto the physical part and then decide whether to use their own manual positioning or choose the auto locate feature. I'm now going to show you a quick video of how this will all work. So with their wrist, the user will have to tap onto it, which will open up the HoloLens, and the user will then have to select the PolyWorks AR app. You will need to have the inspector project open at the time. So you can see here now the user is going to select the inspector project from the app. And this will just take a few seconds to download. As you can see here, a download has been successful, so you will have to select the OK button. So that was just showing you how to begin the part localization. So you can now see the hologram you can control with your hand by pinching. So this will allow you to rotate. So the idea of this is to manually position the hologram onto the part. So you can see here the user is doing different techniques to move the part around. So again, with the pinch of the fingers, he or she is able to rotate. You can also use raise on the model. So you can sort of step away and use the raise to also orientate it, as you can see here. Another technique for the manual orientation of the hologram are these handles that will appear on the bounding box of the hologram. So this will allow you to orientate it sort of through an axis. You do want to get this as close as possible, but it doesn't have to be perfect. And then the last thing that you will do is, as on the slide previous, you will have a toolbar at the bottom where you can either use the auto locate, which will do it for you, or you can accept the manual location that you have created yourself. And then as you can see here, the part has been localized. So there are different techniques that you can choose. And then yeah, once you are done, you will just hit either auto locate or go. There is no longer any installation required on the user's PC. In regards to the HoloLens, you will need the PolyWorks AR for HoloLens app, and potentially a framework package might be required for you to install the first time you use the PolyWorks AR for HoloLens app. The interface has now changed too. You'll now see that even when the augmented reality plugin is turned on in the Workspace Manager options, the option has been removed from the Tools menu in Inspector, as the need for Vuforia engine has gone. The date at which the support for Vuforia will end is May 2021, so we have in fact actually already gone past this date. PolyWorks part localization is supported from PolyWorks Inspector 2020 IR11 onwards. The benefits are that there is no need to install any additional software. There is also no need for an internet connection, previously required to install Vuforia. There is a much smoother transition between PolyWorks Inspector and PolyWorks AR, as there is no need for any project preparation in regards to Inspector. Now, moving forward, I'm now going to talk about some of the brand new workflows that have been implemented for PolyWorks AR 2020. Now, customers who are interested in PolyWorks AR in the past all have different ideas about what they wanted to do with it in terms of how it would help their inspection processes and also their inspection teams. They all wanted to do something different with it. Can we show results on the part? Can we take pictures and videos of any defects? Can we show the DRO? Or can we guide the user with instructions or images? For example, what or where to measure? These are just several examples. There were many requests for many new different functionalities. To unlock as much workflow as possible, macro commands were developed, including creating an annotation, changing the annotation's text, changing the annotation's color, and also hiding an object's annotation. Now, due to a high quantity of user requests for specific new functionalities, there are two brand new supported workflows for PolyWorks AR 2021. We now have a gauging workflow, and we now also have a build inspect workflow. I will be showing you both of those shortly. So let's start with the gauging workflow. Previously, to be able to measure using a gauge device in PolyWorks, PolyWorks would obtain the measurement using a macro script. This is no longer the case because of the new gauging plugin. The solution is that PolyWorks AR 2021 now guides the user to the correct location. The HoloLens will then automatically take a picture once a measurement is acquired. The user can then access the captured image in the object menu, where they can then either view the image, export it, or delete it. So this is a pre-recorded video from Inferred, just demonstrating this process. So it begins augmented measurement with digital gauges.
Okay, the goal is to measure this part with digital gauges. So I have a project already open. I have some objects set to the gauge method, and I created a measurement sequence. So if I run that sequence, you see that I have some guiding instructions telling me to measure the slot 1, the width of slot 1 using gauges. And you can see that if I would be far away, I would have guiding arrows that would point me in the right direction. I can now go and measure this characteristic, and I want to stay there for a few seconds because it's going to actually take a picture of where the operator was during that measurement. He then follows the instructions to the next object. You always see the previous result and the next one, the next object to measure. I'm done. I can see all my results. I can just move annotations out if I need to. And that's it. I was able to do a guided inspection, but with the added benefit of traceability. For any of those objects, if I wanted to review, for example, that circle, if I want to make sure where was that measurement taken, I can go into View, Capture Gauging Images, and look at the picture for the diameter. And while I was measuring, it actually took a picture so I can validate if the measurement was done properly at the right place. Here I built a little macro that just opens all of them. So as an example, I could say, okay, this one's good. They were all measured at the right place with the right device. So this is AR for digital gauges.
The benefits of this new workflow include the traceability of the acquired measurements, the unmatched guidance, and also the ease at which this can be used to help train a new employee. We now move into our second brand new workflow for PolyWorks AR 2021, the Build Inspect workflow. The guidance for Build Inspect is traditionally seen on the computer screen in the top right corner next to the DRO. The solution is that it is now being added to the PolyWorks AR app, as you can see here.
Okay, the goal is to use Build and Inspect with AR. So as you can see, I'm already aligned to the real part. And here in Inspector, I'm going to start the Build and Inspect mode. on those two holes. I'm using the vectors from the cylinders, and I'm going to build and inspect them. So what you see usually on the screen, you actually see directly on the part. So you can take the reflector, put it on the object, will automatically match the right object. Note that you can take the DRO, you can make it larger if you want and put it where you want. And the idea is to locate the holes properly. So as an example here, I'm going to use the arrows to know in which direction to move the part. To go within tolerance, I'm going to lock this one, move to this, and I'll make the needed adjustments. I'm within 0.1, it's not too bad, oh, it's actually really good. Go back and check this again, 0.5, I could improve that a little bit. And as you can see, I was able to go to 0.45 millimeters here, 0.2 millimeters here. Refine this even a little bit more. So you can achieve really good tolerance, all of that without actually looking in the computer.
There are some limitations, however. PolyWorks AR will automatically adjust to PolyWorks Inspector. There is no way to start the process from PolyWorks AR. Also, there is no configuration within PolyWorks AR. But on the flip side, there are some benefits to this new functionality. The ease of use, and also this is a perfect tool for when working away from the computer, for example when using a laser tracker. Now, that brings us to the end of this part of the presentation. Moving into the penultimate section of the changes and improvements presentation, the topic I'm going to share with you all now is in regards to PolyWorks Modeler, more specifically improving the Nurbs surfacing workflow. A new toolbar has been introduced to better aid the user in the Nurbs surfacing workflow. Surfacing tools are already available within Modeler, and the new surface toolbar is hidden by default. I will be demoing this shortly and showing you how to turn this on. The toolbar contains the most useful tools to aid the basic surfacing process. I'm now going to take you through an improvement to an existing function within PolyWorks Modeler. This tool has been around for a while but has been significantly improved in 2021. The tool I'm referring to is the automatic Nurbs surfacing function. The tool is being referred to as the next generation surfacing solution for smart reverse engineering. Departing from the traditional approach that covers polygonal surfaces with small tiles of similar size, PolyWorks Modeler 2021 proposes a new groundbreaking automatic surfacing algorithm that draws characteristic curves over a polygonal surface and partitions these surfaces into a minimal number of patches. Users can model a polygonal surface with a single click by automating the creation of curves and the surface patches and fitting a continuous network of Nurbs surfaces. It can create CAD-friendly models editable within CAD/CAM applications by automatically bounding surface patches with continuous curves that naturally describe the part's characteristics. It can also produce lighter models for downstream applications by automatically adapting the patch size and aspect ratio to the part's surface curvature. Users can now simplify their reverse engineering workflow. PolyWorks has integrated the automatic surfacing technology within its intuitive curve-based surfacing workflow, allowing users to get the efficiency benefits of an automated solution while enjoying the flexibility of interactively editing the curve network to create optimal surface models. It is now possible to control the geometric description of critical part features such as boundaries, sharp edges, and fillet tangents by providing predefined curves to the automatic surfacing tool. Then, users can edit the automatic surfacing results intuitively by adding, deleting, or reshaping these curves, as you would do in a manual reverse engineering workflow. And finally, filter out unwanted details on the polygonal surface after the initial automatic surfacing process. Then quickly rerun the algorithm to resurface the edited section. So, what is the need for the change? Well, the existing functionality did a poor job. The tool created incomplete models and had poor patch structure. Not to mention, the manual reverse engineering process takes time. Now, is the Auto Nurbs tool one click? In a word, yes, but it is recommended that the user makes use of existing functionalities, first to construct boundary curves as well as cleaning the model, removing any defects such as peaks and floating triangles. The user could also potentially make use of other curve tools too, including tangent or edge curves. As I mentioned previously, PolyWorks Modeler 2021 has a new surface modelling toolbar. This should be considered to be used as guidance when using the Auto Nurbs tool. The Auto Nurbs tool does now have a new interface as well. You can see that you can still use selected curves. In the Advanced tab, you have access to the minimum angular feature detection span, defaulted to 30 degrees, and also a max relative patch size, defaulted to 15%. I will be going into these in more detail just now. You may have noticed at the top of the new interface, it asks the user whether they would like to use selected curves. These curves will impact the results. If you make use of selected curves, these curves are considered, deleted, and then recreated. Selected curves are used mainly for boundary curves. They should be inserted into the polygonal model for better results. They are mandatory for open models. Closed models, on the other hand, have surfaces all over, so do not require them. As mentioned before, tangent edge curves can also be used to better guide the algorithm. Now, for the minimum angular feature detection span. Angular span is when we have a change in shape on the model. If the value entered is smaller than the minimum angular span on the model, then no curves are created. If larger, curves will be detected. You will now see the effect that the value of the min angular feature detection span will have on the created curves. If you focus specifically on the arrows, you will see a higher value on the right hand side reduces the number of curves created, as the angle of the change in shape on the part is preventing the detection of curves within the algorithm. As for the relative patch size, that is determined by the bounding box of the part in question. A larger value will produce larger patches on your models. So I'm now going to demonstrate the new Auto Nurbs tool in PolyWorks Modeler. So here in Modeler, I have the imported sheet metal part as a polygonal model. The first thing I'm going to do is turn on the surface modeling toolbar that I've been talking to you about. So I can right click in the empty space up here and go down to the surface modeling tool. Now, users of Modeler will be familiar with some of these icons as they are already integrated into the software. It's just this new toolbar is to allow for the basic reverse engineering process. So we have here our polygonal model editing tools, so interactive hole filling, smoothing, and reconstructing. We then have our curve tool. We then have our fit curves, insert curves, and then we have create Auto Nurbs and our curve editing tools here as well, and then our fitting our Nurbs patches. So the first thing I'm going to do is to check the part for any defects, and all seems to be okay. So at this point, I don't really need to use the hole filling tool or any of the others here. So the first thing I'm going to do is create a boundary curve on the model, and I'm not going to make any changes in here, so just hit create. And if I close that down, you'll see that creates our 4 boundary curves. Next thing I'm going to do is insert these curves into the model. So I'll do this bit first, insert. Once I've done that, I can then highlight my 4 boundary curves, as you can see here. I'm then going to hit on create Nurbs patches from polygonal model. And as I mentioned, we can use selected curves. So again, my 4 boundary curves have been selected. And I'm going to leave the values in here as default. And now I'm going to hit create. So you can see here the curves have been created. Relative to 2020, the grid structure that you can see here has improved. In 2020, for example, curves would not always go up to the edge of the part. It's not perfect, as you can see, as there are still some T-junctions that can be improved afterwards using the curve editing tools. And now we have our Nurbs patches here, so I'm going to fit all of those. So I can either manually select them and use the unfitted Nurbs patches, or I can just do all of them at once. So fit all Nurbs patches. Hopefully this won't take too much longer. Almost there. There you go. So we can see that it's now been fitted. So what I'm going to do, just to show you the fit, I'm going to turn off our curves, and then in my object display options, I'm going to change my color mode for the Nurbs patches to fitting errors, and then turn off my polygonal model. So you can see here we do have some slight distortions in the models. So as I said, it's not the perfect tool. So you may want to go in after now and edit some of these curves using our edit curve tool. So again, any questions on this technique, please make note and I will be answering any questions you have on this at the end. The improved technology allows the user to model a polygonal surface with a single click by automating the creation of curves and surface patches and by fitting a continuous network of Nurbs surfaces. You will also be able to create editable models suitable for CAD design and simulation applications by automatically bounding surface patches with continuous curves that naturally describe the part's characteristics. And finally, it is now possible to produce lighter models with better fitting accuracy and patch continuity for downstream applications by automatically adapting the patch size and aspect ratio to the part's surface curvature. Once you have used the Auto Nurbs tool, you can still edit the surfacing results by adding, deleting or reshaping curves, as you usually do in a manual reverse engineering workflow. You can also control the description of curves that are critical for the intended application, such as symmetry lines, part boundaries, and subtle feature lines by providing predefined curves to the surfacing tool. There are some limitations, however. For the moment, we know that the algorithm is a little sensitive, so you need to have a clean and smooth model. That is really important. Otherwise, you are going to get indifferent results. Make sure to remove floating triangles and avoid peaks and valleys. I have a few examples to show you in a second. If you can scan within Inspector, the model should already be smooth enough to prevent this problem. But if you bring in the scan from an external source, you may want to run the smooth tool. Peaks can occur from shiny parts, so not removing these peaks can result in algorithms producing crazy results. The algorithm is being constantly reviewed and improved, so I am told that in PolyWorks Modeler 2021 IR1, this possible issue has already been improved. Floating triangles can be described as an island, a piece of scan that was not connected to the model, which can also cause some crazy results. Here are some of the applications for the improved tool, dependent on your area of interest. And that brings us to an end of this particular section. Again, any questions you may have, please make a note of them and I will take them at the end of the presentation. As for now, we are going to move into the fourth and final part of the changes and improvements presentation. This topic looks at a change to the Airfoil gauge tool, specifically looking at the new tolerance blending option. I will be demonstrating how to create these tolerances, how these tolerances blend shortly, but first a bit of background on the subject for those less knowledgeable. We have here an aerofoil where we are about to create an aerofoil gauge. This will create the following measurements, such as max width, chord length, and a few others. Once created, you can then access the aerofoil object properties and make amendments if necessary, such as setting gauge type parameters. In PolyWorks Inspector, within the Analyze Segments button, the user could specify segment tolerances, but as you will see on the next slide, this will create a step graphically on the accompanying cross-section if the segment tolerances differ between segments. As I mentioned, you will see on the cross-section here the step between the segments when the tolerances have been changed. Some of our customers have requested that this step is no longer a step and more of a transition due to information specific to drawings. Now I can't show you any of these drawings due to confidentiality reasons, but I have pulled some quotes from said drawings. The first was to blend smoothly with remainder of aerofoil section profile, and the second, tolerance band in these regions should be to be a smooth transition between adjacent tolerance bends. It is possible to control the tolerance blending with regards to the neighbouring segment. You can either leave it as you've just seen previously, or you now have the option to blend, either linear or smooth. It is also possible to control the blending length. We now have an example with no tolerance blending. Now with trailing edge linear blending, and now with smooth, and back to none again to show you the transition. We now have linear. Again, linear now on a few different options on the pressure and suction segments too. And again, back to none, just so you can see the differences here. Now, instead of linear, we've smoothed the transition from the trailing edge. Smooth again, only this time again with pressure and suction. And just to show you, this has been available since PolyWorks 2020 IR10. The default values for these blending tolerances can be found within the PolyWorks Inspector options in Objects, Gauges. So just here in the options. There is also the option to best fit each individual segment to the reference object within the tolerance zone, found here. This will have no effect on the airfoil measurements. As you can see, the best fit cross-section within the airfoil's properties is unaffected. Benefits of this improvement: it is now possible for users to inspect airfoils as requested on their drawings. And it also allows the users to best fit segments and compare them to reference objects, considering a transition zone between the different zones on the airfoil. To finish, I will quickly demonstrate the key steps required to be able to create these tolerance bends. I'm now going to show you the airfoil tool and the changes to the tolerance blends. So we have here an inspector, we already have a blade, and it's been aligned using a best fit. So I'm going to go to our gauges tool and then create airfoil gauge. And I'm going to use the along standard axis, and I'm going to change it to Z, and then just anchor a point here on the airfoil and hit confirm. So that is our airfoil gauge. And the first thing I'm going to do is show you where you can change the blend tolerances. So if I double click to access my airfoil properties, and then if I hit the tabs here, you can see here we have our analyze segments. So I will need to turn this on and jump into the options. And the first thing I want to do is just quickly input the tolerances for our specific segments. So difference between the pressure and suction and the leading and trailing edge. So we'll go 50 microns for those and 0.1 for all the others. And then I'll just finish off by manually typing in some values for our suction and pressure. So we'll give that one 25 microns. And I'm just going to OK that. Now you can see our tolerance blending here, but I will show you how it works before we input those. So if I hit OK, you'll see on the annotation we do get some different change you'll notice here if you've seen that. So I'm going to close down the properties window, and what I'm going to do is right click on the created cross section that accompanies the airfoil, and I'm just going to view that on its own. So you'll see here we have the cross section for the airfoil. The first thing I will need to do so that you can see the changes I'm about to make is go into my object display options, and first of all I'm going to tick off the hide colour map. So you'll now see we have the colour map on the cross section, and also show you the tolerance curves. Now you'll notice that there is no step on this cross section. The step only applies in a second once I've created some airfoil gauge cross sections. So to be able to do that, I will first of all click on our airfoil 1 and then go to cross sections, create standard cross section, and then my method here is going to be from airfoil gauge segments, and I will leave them all turned on to show you. So if I hit create and then close that down, you can already see we have the step here. So I will hide the initial cross section and the final two so you can see. So we have here at the leading edge end, you can see the step there. The distance in step here, that's not caused by the tolerance, that is caused in your object display options by the scaling factor here. So if I was to change that to 10, you will see that that does increase that. So that is just a graphical display option there that you can edit. So to be able to put the smoothing on, whether it's linear or smooth, what I can do is go back into my airfoil properties, back into Analyze Segments, and then I can change my tolerance blending here. So for example, we will use the trailing edge. So in my trailing edge row here, I will change the tolerance blending to blend with neighboring segment, and then I will leave this on smooth to show you. And then, as I said before, you can specify the blending length also. If you want to do this to all of them at once, you have the apply to all segment extremities tick box here as well. So just for the time being, I'm going to leave that off just to show you. And then again, we have best fit segments within the tolerance zone. So that will best fit each segment to the reference object. So if I hit OK, that will update the trailing edge for us. And you will now see on the trailing edge, we have our smooth blending option here turned on. And then just to show you again, I will jump back into there and change that to linear, hit OK, and that will now update for us. So you will see it's slightly changed. So instead of smooth, it is now linear. And what I will then do is apply that to all of our segments. So you can see how that works across the whole of the airfoil. So if I come back to the leading edge, you will now see the same here. So just to summarize, you will need to, first of all, create the airfoil gauge. You will then need to turn on the object display options, so it will show exactly what you're after. So you will need to make sure that the tolerance curves are showed. You will then need to jump into the airfoil gauge options and change the tolerance blending, which wasn't available in 2020. And then you will, as I've just showed you, you will need to make sure that you create these cross sections here. So once again, in cross sections, and then from airfoil gauge segments, and that will give you the tolerances that you are after. Well, thank you very much for all of your questions. We're now going to take a short break, roughly 10 minutes or so, and when we return, Connor Raleigh will be showing you the features and functionalities presentation. See you shortly.
Good morning, and thank you again for joining our conference. Here are some of the new features and functions that have been brought into PolyWorks Inspector for the 2021 release. This year, due to popular demand, PolyWorks has introduced the ability to measure line profile GD&T on features and cutouts. PolyWorks can measure line profile for a full or partial area, to datums or just to nominal. Let's take a look in PolyWorks to see how this tool works and the added benefits that come along with it. So I'm just going to open up my PolyWorks, and I'm going to choose my workspace and just download it from the data loop. Okay. I'm going to choose the project, and we'll open that up. So the part is an aileron hinge. Okay, so it has a datum on the back face, it has a datum through the central cylinder, and the area that we want to check is where the hinge would, I suppose, rotate about. Okay, so this cutout here is quite important because that controls how much the aileron can rotate. So we might want to check the line profile to make sure the cutout is as it's supposed to be. So to create a line profile, what we now do in PolyWorks is we create it as a feature, but we choose it as a polyline feature. Okay. We can create it as a single segment or as a multiple segments. And we can do the full curve or we can do a partial curve. So a lot of the time it'll just be a partial curve that'll be called out for on the drawing, and it's a simple matter of, like what we have with our cross sections, just choose the partial curve option. In this case though, I'm interested in evaluating, I suppose, the full curve. Okay, so simply select it on the CAD model and it'll pull it out. Okay, and we can see here in our tree view we have a polyline. I'm just going to move these annotations out of the way. So let's have a look at our extraction parameters then for measuring our polyline. You can probe them as well, but in this case we're just going to extract it as we have scan data already provided. So very similar to how we currently extract circles, we choose the max distance to the nominal primitive. So I'm just going to leave that at 4 mil. and again it's going to extract a local plane first, same as a circle does currently. So it'll extract a local plane on the top face, and then it'll come in and look at the edge or the wall face of our cutout, and then pull out the scan and give us our result from that. Okay, what I am going to turn on is our max angle, and I'll explain a little bit of how that works in a few minutes. We'll hit apply to that. Okay, and we will extract our polyline now. Okay, so that's now pulled all the information out from the scan data. What I'm going to do in the geometry controls is I'm just going to add a line profile GD&T, and I'm going to tell it it's coming from A and coming from B as specified in the drawing. Okay, and we can see a result getting pulled out. I'm going to turn off that I don't want to see the length value at all. So I'm just going to show us our scan and hide our CAD. Okay, and I'm just going to evaluate where the scan or what area of the scan the information has been pulled from. So I'm going to select, and I'm going to select first of all the measured data points that it's using to measure the local plane. Here is where we can see how our max angle works. Okay, so anywhere that's highlighted in red, we can see it's pulled out those points and it's using it to create the local plane. As the curvature changes on the top face here, and this becomes a fillet, we can see that PolyWorks automatically knows not to take those points. And that's because those points normals don't fall within the 30-degree range that we set to the CAD model. So the polyline knows it's supposed to be in that area on the CAD model. And if the points normals change from beyond 30 degrees, then it just stops taking them. Okay, so it becomes quite an intelligent tool then. We can as well select the data points inside our cutout, and we can see all the points then that it's using as well for measuring the polyline inside. Okay, we have those functions already built in, but we hadn't done them before for a polyline. We had them for circles and other 2D features. So we have our polyline picked out, but we might want to delve a little bit deeper into it and maybe view our feature navigator. Okay, so that will highlight the component that we're interested in, so our polyline, and then we can highlight the control that we're interested in. So we're interested in the line profile. If we turn on show deviation vectors, okay, what that will do is it will give us deviation vectors all around our polyline, and if we just want to make them a little bit bigger, we can up our scaling factor as well. So we can see that we are low material in some areas, and we've gone a little bit high in other areas. Okay, so in the likes of here, I would suggest maybe this might be a problem. So if this part is swiveling about a dowel, then the dowel is going to stop short on this area. Okay, so to report this, we can just create a screenshot. Okay, add a title for our report. Okay, and continue on and measure the rest of our part. But we can see now in our report that we have exactly what we had wanted to see. Okay, so let's jump back then to review some of our other features that we've been working on. So the next major function that's been added is splitting measurement steps. Okay, splitting measurement steps in PolyWorks allows us to create measurement sequences which have measurement steps for the same feature split into different areas of the sequence. As you can see from the image of the sequence, the same feature has been split up into different steps of the sequence. We are going to look at how we do this today on a CMM. But bear in mind, the same principle can be used with laser tracker, measuring arm, or hand tools. Let's take a look at how this works. Okay, so I've opened up my workspace manager again, and I'm just going to go into my machined bracket. Okay, So the part that we're opening up here has a few features that need to be measured as one, but they're on two different surfaces. And to create the sequence efficiently, it's better to actually split up some features. So, but we'll have a look at these as we go through it. Okay. I'm going to show two different methods as well. So the first one I'm going to show is having the software split the features by itself, using its sequence creation technology. And the second one, I'm going to show how we would do it manually. So I'm going to start off with this bearing axis. Okay, now I've already got some steps in, so I'm just going to execute these. So I'm just going to run the sequence up to, and basically all it does is it puts our CMM in a nice starting position for me. Okay, so let's have a look at our properties of our bearing axis, and let's modify them. So we have 2 circles to measure, and I'm just going to up my number of points to 4. So it's going to take 4 points in the center, or in each of these faces. Now, what I am going to do as well is turn on the endpoint exclusion. So I want to come in about 8 mil from the edge. Okay, so I'm taking points more central in each cylinder. Going to turn off my movement before and my movement after, as we are going to be splitting these up. Okay, and I'm just going to hit apply. Okay, from there, I'm now going to jump into my edit sequence and measurement path interactively. Okay, this mode, if you haven't seen it before, gives us these tools on the bottom. Okay, what I am going to make sure is that PolyWorks is given the ability to automatically select tools and tool orientations. So that means that it can change its tool orientation by itself, and we're not locking it into a position. We will be doing that later on, so I'll show you again how that works. Let's now add our bearing axis by highlighting it, and we're going to add the selected object to the end of the sequence. Okay, PolyWorks will now put that feature into the end of the sequence, but it'll also split it into 2 halves, or 2 measurement steps, and it'll add go-to positions and a head orientation change in the sequence as well. So if we just have a look at what it's done. So it measures the first half, it knows to back off, it knows to change its head orientation to get around to the other side, and it's now measured the other side. Okay. Now, what I'm going to do is continue on now. I'm going to measure some other features, and we're going to just go through that same sort of process, but we're just going to do it manually. Okay, so what I want to do is start out at a good position. So I am going to just drive my CMM out of this hole, and I'm going to add in a go-to position. Okay, an easy way to do this, okay, in simulation mode, is to use the up, down, left, right arrow keys. So if I press down on my arrow key, I can move the CMM down, and if I press the right button, I can move it to the right. Okay, another tip is if I want to add a go-to position into this location, I can simply hit record on my sequence editor and hit insert on my keyboard, and that's now added this go-to position at the end of my sequence. Okay, so finished with my bearing axis, and I'm going to move on to this this next cylinder. Okay, again, going to set up some parameters for the measurement of it. So we're going to tell it it's CNC probe, submethod, we're going to standard, a number of circles, I'm going to change that to 4. Okay, and we can see there's some warning flags up here, and we can change the number of points per circle. Again, we'll keep it consistent, and we'll keep it on 4 as well. Now, I obviously have points in here in the center of the part that it can't measure. So what I'm going to do is apply the current changes. I'm just going to put this back onto 4. Okay, and I'm going to get rid of the movement before and movement after, because again, we are going to be splitting this feature up. And the measurement points, I'm going to I'm going to modify. So if we go to our measurement points, we have highlighted now on the left hand side of our list of measurement points, we get highlighted any ones that there's going to be a problem with. Okay. We also as well have now numbered the points, so it's very, very easy to recognize which point is going to be first, second, third, or if you're worried about any sort of area, you can easily see and modify them by this list. Okay, so I've selected 5, 6, 7 and 8, and I'm just going to modify these and move these in the x-axis. So my x, I know that I want these actually at 80 mil, and our preview changes straight away. And because this part is symmetrical about the center, I'm going to change these points to minus 80 mil. Okay, so now at least our points are in the correct orientation or the correct position for us to measure them. So I'm going to close now out of my properties. What I'm going to do is I'm going to add my cylinder to the end of my sequence. Okay, and we obviously get collision detected. So if we analyze that issue, we can see that after it's measured the first half of the cylinder, it's currently going to try and drive itself through the part to get to the other side. So let's split our feature up into two. Let's then add some go-to positions and a head orientation change as well. So to split our feature into two manually, what we can do is we now have a little plus icon beside our feature in the feature tree. So I know that 9, 10, 11, 12, 13, 14, 15 and 16, they are all, I suppose I want to split them into their own feature. One way of doing this is to right click and create step from measurement points, or we can simply drag these points and then out of the feature and just put them on their own as their own step after that. Okay, so we still will have an issue, okay, because our head, whenever it goes to do this second half of the cylinder, is going to be in the wrong orientation. So what I'm going to do is just insert at this stage a head orientation change. Okay, and I'm going to use our picker because I'm not familiar with A and B angles, for instance, or I just want to make sure. So I can use the picker, and I can choose on screen or on the CAD model then which A and B angle I should be at to measure that feature. So it's just a matter of highlighting over the surface and it'll give me the head angle and orientation to be at. Okay, so we still have an issue. Okay, so problem is that before it does its orientation, it's still just too close to the cylinder. So what I'm going to do is I'm going to insert a go-to position. So I'm going to insert a go-to position, and like the picker, I'm just going to choose it from the CAD model. Okay, so using my rotate button on my mouse, I can choose the distance from the CAD model that I want it to be at. So now that issue is gone, so it can now do its tool orientation change, and then after that it's going to try and come over here. But again, as we can see here, the CMM is going to try and drive through the part. We can fix this very, very easily by hovering over the collision detection warning and hitting the insert go-to position steps. Okay, PolyWorks then will automatically bring itself around the problem area and figure out how to get back down to then measure the feature. So if we have a look at that, we can again execute those selected steps, and we can see it measuring one side first, go to its go-to position, and then it can measure the other side. Now, one problem with this is the CMM was already over here to start with. Okay, so we might want to now modify our sequence. So since our CMM started in this feature over here, we might want to get it to then measure this half of the cylinder. and then come over here and then measure these two halves. So what I'm simply going to do is I'm going to drag this half of the cylinder up. Okay, so it's now beside the where it's already. Okay, what we can do is then at the end of our sequence, we don't need this extra head orientation and movement step at all, so I can simply delete these steps. So I can just drag them out of the sequence and they get deleted. Okay, so we can see still though we have some extra steps that may need to be cleaned up. So after it's measured this step, it then comes all the way over to here, which it doesn't need to anymore. So what we can always run is we can use our optimize go-to positions. Okay, so even if you have steps, you can ask PolyWorks then to optimize your steps. Okay, so now we have a nice straight sequence getting to measure the two cylinders, but separated out into 4 steps, and 2 of them on the left hand side first, and then the 2 on the right hand side. So let's move on and let's have a look at measuring our next features that have been called out. So we have datum plane A, which again it's going to have to split up for us, and then we have some other features that have to be measured also. So what we can do is go through and have a look at the parameters. I've already filled in the areas that need to be measured for our planes, so we will add that to the end of our sequence. So like what we did at the start with our first cylinder, I'm just going to select datum plane A. Its properties are already filled in so that it already knows to measure it in those locations and its CNC probe measuring. And I'm going to tell it to lock it to A0B0. So I want to make sure that CMM measures this plane on the straight down position. Okay, so I'm just going to simply now add the selected object, being datum A, to the end of our sequence. PolyWorks is now going to calculate the head orientation change, movement, and then work out a path to get around and measure the feature. Again, highlighted up, we have a go-to position that is highlighted now. Currently, it's given us an error because our CMM is over here, but at the end of our sequence, it actually finishes over there. So if we put our sequence into position, this is where it would actually have finished. Okay, and that's only because we've changed manually earlier the order that we were working in. So now we can see our collision detection and avoidance has gone away, and we can see that it's done a head orientation change, this dotted green line, and it's working its way counterclockwise around the part to be able to avoid these high areas and these cylinders that would normally get in the way. And it's split up the datum plane into 6 different steps. So we're happy with that, but we have other features that we also want to measure. And we might want to measure these features, such as these angular faces, such as these M10 holes, and such as these surface points that I'm actually using to measure first, to then create my offset distance to know how far down into the M10 hole to go. So we are going to select those features, okay, and go back into our edit sequence and measurement path. And in this case, I'm going to keep it on A0B0, but I'm going to ask PolyWorks to add the selected objects to the optimal location in the sequence. So it already has its sequence to work its way around the part in A0B0. And now it's just going to fill these features in to the best location. So we can see that even though there's plane 1 in there, or datum A, in multiple steps, it can again add separate features in between the measurement of features. Okay, so that's added all those features in, and if we just get a quick preview, we can see that it's a nice clean path. It's never coming to the same area twice. While it's measuring a plane's point here, it's then going to measure the M10 hole and the surface point and continuing on along its journey. So you get a much cleaner path without having to, really think too much into it. You just tell it what features need to be measured. Okay, this is very, very useful, I suppose, not just for the CMM, but for the likes of a laser tracker or an arm, where you might have a big part and you might want to measure certain parts or certain features on the left hand side of your part first, and it might be the same feature that's on the right hand side. So if it's a long plane with a lot of holes in it, you can measure the points for your plane as you measure your circles or cylinders. Again, for star probes on CMMs as well, it can be quite useful, because if it's in one area, it can measure plane and a circle's points at the time when it's in that location. So I'm going to jump back out of PolyWorks again now and close it down, and then we'll keep going through the rest of our new features. So we move on to our measurement system analysis. For 2021, PolyWorks has looked at making the most out of its integration into Excel. One of the benefits of this is creating templates for measurement system analysis. SPC tools contain methods to determine the stability of processes, to control the processes to ensure customer satisfaction, and to establish indices to quantify the capability of the process to meet the customer requirements. Those tools help to identify special variation in manufacturing process, to correct it as soon as possible. To detect these variations, it is essential to keep the measurement system variation as low as possible, in comparison to process variation. Otherwise, SPC charts could lead to wrong conclusions. The measurement system analysis, or MSA, helps identify performance of the measurement system. There are two main types that we will be focusing on here: repeatability studies and gauge R&R studies. Repeatability studies assess the variation of a measurement systems when affected by a minimum number of sources of variation. In a gauge study, an operator takes one piece, places it in a fixture, measures the piece, takes it out of the fixture, and repeats this cycle multiple times, always using the same piece. The gauge R&R is an approach which will provide an estimate of both repeatability and reproducibility for a measurement system. This method decomposes the system variation so we could analyze the equipment variation, but also the variation due to the operators and the manufacturing processes. This is the new MSA toolbar that has been introduced into PolyWorks. It has 4 main steps in PolyWorks: selecting the characteristics you want to use, designing the type of study you would like to perform and how you would like to analyze the data, measure the parts, then publish the study to Excel. This will be our workflow, which the order of the toolbar buttons takes us through. When designing the study type, there are 4 built into PolyWorks and available on the technical support zone. For repeatability studies, we have type 1 gauge study and gauge R study, which can then be analyzed in average moving range and sample standard deviation. For gauge R and R studies, we have the ANOVA method and the average and range method. I'm going to go through this process for a gauge or study. All of the analyzation will be taken care of without having to do any calculations or data inputting. The benefits of this will be clear. So what we will do is we will go through this in PolyWorks. So I'm going to open up this. And we have our part now that we are interested in. Okay, and we only have one piece. So we've measured our first piece and we have imported the CAD and the features that we're interested in. So we've now turned on our new toolbar, which can be turned on, turned off, depending on if it's needed or not. And we're going to select then our key characteristics. So in this case, I'm just going to select all of them that we're going to be using. Okay. That now will give us them in Control Reviewer. And we just want to set up a nice image for our Control Reviewer, so when it is time to review it, that it is set up nicely. So we're going to now choose what type of study we want to do. So we have the repeatability or the gauge R&R. And we then have a type 1 or a gauge or study. So we fill in our part name, part number, gauge name, and operator name. These are all going to be, I suppose, kept with the part all the way through into Excel at the end. So it really is just guiding us through how we want to do our study. So we're going to do it with 10 parts, and we're going to do it, measure the average moving range. Okay, so it's going to create a template, so we don't have to. And then what it's going to do is it's going to create our 10 blank pieces. So it's basically getting ready for us to measure our pieces by creating them. So we're then guided through to measure them all in the next step. So that's all ready to go. And we have our 10 pieces. So it's a matter of inspecting the next piece now. So we've obviously done number 1. Now what I'm doing here is we were just importing the scan, but you would, like always with PolyWorks, you'd be just guided through to measure the part the same way as you'd measured it the first time. So whether it was scanning, probing, whether it was on a CMM, you would just be taken through the sequence to however you have it set up. Okay, so we've sped this a little bit up. So we don't want to, because it's all fairly repetitive here, where we're just going through the measurement of each of the 10 pieces. And we can see even just from on screen now how surface point 2, if we focus on that, is deviating over the pieces. So it's falling within and out of tolerance. So here's our last piece being measured. So that's all our measurement done. So there's our 10 pieces. Again, the operator is told, you've finished all of them. So now it's time to publish our study. Okay. Now we will be asked to select our template. So here we are. To use for publishing our study. These are available on the technical support zone, and it's just a matter of browsing the software to it. So depending on which study you're using, you choose that study from your file explorer, and it will then open it up and populate it in Excel. So now we can see our gauge or study has been compiled with all our characteristics and all of the values. Okay, so we have our study results, and then we have a separate sheet for each characteristic that we have chosen. So all the time is taken out of having to measure your parts, make sure you've measured them in the same way, export all of your information, fill it all into Excel. This takes care of everything and gives it a very nice format so that you can make sure, you're happy with the process or you're not happy, and you have 4 different types of processes to be able to monitor now as well. Okay, so there's our last characteristic, and we're back then to our presentation. So, in conclusion, for the MSA toolbar, the benefits really are that customers can now move from a paid specialized software like Minitab to an accessible one like Excel. For streamlined processes, there is no need to send data to an external software for calculation and then to bring it back. The user can do everything at the same place in the PolyWorks digital ecosystem. The value inputs automatically instead of manual value entry. And for repeatability especially, it preserves a live native link between the report and the inspected pieces. So changes are tracked and adjusted. Finally, since everything is located and calculated in one solution, it is simpler to ensure traceability of the analysis process. We have had a lot of customers wanting to use PolyWorks for CMM program creation, as they are finding our user interface is better, more intuitive, and the collision detection to be extremely useful. A big reason to export from PolyWorks is to have the ability to supply customers or suppliers with the same program that you use, but the ability to run it in their own software. So we have updated our export to DMIS. Okay, so this new functionality to export is located under the file, then export, then sequence. You then have the option to export only certain steps of your sequence or all of the sequence. It can also be accessed from the sequence menu. Bear in mind that not all functions are going to be available to be exported. Now we move on to Styli calibration. Okay, a very useful and time-saving tool has arrived for Styli users. The ability to calibrate all head orientations by using the Inferred method. This was released in the IR9 version in 2020. This means that by calibrating a few orientations on a Styli tips, all the orientations become available to use. This becomes a massive time saver, as it means time spent on calibration is dramatically reduced and your CMM becomes more adaptable to changes in parameters. In PolyWorks, you now get the ability to change the tip to use when creating or changing the tool orientation. The picker will now display the tool tip in its full name, and the probing device toolbar allows you to change the tip you want to use directly. The calibration style will also soon be released for CMM users running their CMM through Renishaw's UCC server. Offline mode is now available for Hexagon scanners via their I++ server. PolyWorks has been able to connect and run Hexagon scanners on CMM since 2019. However, it was through the I++ server, and it still is. Offline simulation was not available while using this. Now, however, the scanner is built into the software so that the offline simulation can be calculated. To do this offline, connect it through the CNC CMM plugin. Once you are happy with the program, connect to and run the machine using the I++ CMM plugin. The scanners it is available for are the HPL 10.6T, the HPL 5.8T, and the HPL 20.8T. The C angle is also available for offline simulation, so you can allow PolyWorks to completely optimize your toolpath. And the adapters to change the angle of the head by 0, 30, 60, and 90 are now also available. We move on now to the Quality Information Framework, or QIF for short. In PolyWorks 2021, translators will be available to import QIF files and read all the associated information. So, In August 2020, the Digital Metrology Standards Consortium, or DMSC, announced the QIF 3.0 metrology standard was harvested, approved and published by ISO and a new ISO standard. It seeks to resolve technological inefficiencies and other issues related to digital metrology. QIF is a free XML framework standard and defines, organizes, and associates quality information. Digital data must be intelligently organized and passed efficiently through the supply chain, including measurement plans, results, part geometry, and PMI, measurement templates, resources, statistical analysis, and more. So, who does the QIF appeal to? Firstly, it appeals to metrologists. It can be shared between the supply chain, showing how and what to measure, as well as showing the results of the measure. It appeals to PLM or PDM or owners. QIF can take the quality information into the digital thread or system of your manufacturing operation and associate the quality information directly to your master model. Metrology software implementers, QIF is an unambiguous, holistic, fully digital standard for metrology information. This will help software implementers, whether your organization is large or small, in producing and/or consuming quality data. Think of it like a STEP or an IGES file, but with the power and ability to hold much more quality information. So, one of the new features added to our GD&T toolbox is now the ability to unequally dispose surface profile values. Both ASME and ISO now allow for unequal tolerancing of surface profile tolerancing. Their way of displaying the tolerance is different, however, depending on which standard you work to. The two examples here actually mean the same thing. With ASME, the first number shows the size of the tolerance zone, and the second number shows the offset to the upper limit of the tolerance to the nominal surface. With ISO, the first number is the same. It shows the size of the tolerance zone, and the second number shows the offset of the center line of the tolerance zone to the nominal surface. The reported value now comes from the center line of the tolerance zone rather than the CAD surface, which is also in line with both standards. PolyWorks can now connect directly into PLM systems through data loop. Connecting into a PLM system means that all your CAD models can stay securely in the PLM without having to be exported or saved out. This also gives the measurement team direct access to the latest revision of the CAD model. This takes any error of using an incorrect revision or version. It also means that the part information, such as description or ID, can be added and followed through into PolyWorks. Currently, we can connect into Siemens Teamcenter, PTC, Windchill, and SIM database. Here is a quick run through just to show you the process. So very, very minimal change to a user. They can import the CAD. They just get a new option now to connect straight into their PLM. This really does save the time of designers having to save or export IGES or STEP files out from their PLM. And it saves your storage. So everything is still saved in the one location that you're currently using and doesn't need to be exported out. It also is more secure. So you can, I suppose, filter out or see what you're using depending on what you want to see. Now, all of this information, like your current ID, the description, the person who's modeled it, can all come straight into PolyWorks. So you get direct access into the information, and we can see that in the piece properties here. So we can see the ID, the owning user, the revision that it was currently on. So information that's filled in your CAD package is now coming direct into PolyWorks. So let's move on now to the Mitutoyo U-Wave systems. Okay, PolyWorks now has a plugin for connecting to Mitutoyo hand tools via its U-Wave. Simply turn on the plugin for the Mitutoyo U-Wave at the Workspace Manager, change your gauging device to Mitutoyo U-Wave in Inspector, and connect. Measurements taken on the device are now sent to the computer and PolyWorks wirelessly. The computer will need a receiver connected to it, which can connect to multiple devices simultaneously. This is extremely useful when multiple gauges are required per part. Benefits on using gauging devices with PolyWorks include speed of use, as it takes away manual processes like entering nominals, measurements, and tolerances. It also negates the error of an operator filling in an incorrect value. PolyWorks can convert incoming units if required. It will guide the user to where the measurements need to take place. And PolyWorks can store device information which can be referred back to calibration certs to save time on audits. A new feature this year is hooks. Okay, these will be part of our PolyWorks macro scripting. So let's look at macro scripting currently. It is a very powerful tool as it can automate repetitive tasks, automate processes, perform checks, and even generate external files. However, they usually require a manual user intervention to be executed or need to be part of a sequence. What hooks can do are monitor what the software is doing and can trigger a macro to be run before or after an action. Some examples of these that have been requested are to load or give the option to load a visual layout after opening a new file, create a new piece or launch play inspection after a project has been opened, set property values before saving or closing, block upload to data loop or continuation at all if all conditions or properties are not yet met or filled in. Hooks will allow a higher level of flexibility into the software as it can adapt, customize, and automate efficient metrology workflows by monitoring what the software and operator is doing or not done. It is invisible to the end user, but they have a helping hand in the background reminding them of steps they may miss. It reduces errors by minimizing manual user interventions, and they can be used to simplify the user interface dependent on what task is being carried out. It will address metrology processes such as control user access, manage alerts and notifications, automatic validation or definition of state before or after an operation, and automatic generation or update of metrology technical data package. Now we've come to the end of my presentation. Has anyone got any questions that they would like me to run through?
It's remarkable to see where PolyWorks started and where it is today. Now it provides a universal platform that interfaces with all 3D measurement devices and allows you to perform all inspection tasks using one universal workflow. It offers a 3D measurement data management solution with web and mobile interfaces and interconnections to PLM systems. PolyWorks facilitates model-based definition for 3D measurements through CAD add-ins that ensure perfect interoperability with CAD software. And it's an open solution that works with other digital platforms and measurement software. Innometric's smart 3D metrology digital ecosystem components are designed to be deployed gradually and incrementally. That means you can digitize your processes at your own pace, make them simpler, easier, and more efficient while your operations remain fully functional. Today has been a PolyWorks 2021 update training event. However, if you want a demo or a trial of PolyWorks on your CMM or data loop, please don't hesitate to contact us. We are ready to become your digital transformation partner and help you move forward confidently on your journey. Thank you for joining us today, And if you have any questions after the event or wish to see anything featured in one of our webinars, please contact us via our website or contact us directly.